Started. So, hi everyone. I'm Shrisham, and I'm a DevRel engineer here at Preset. And today we're just going to be talking a little bit about data modeling. Maybe this is a topic that's familiar to you, maybe it's not. This is just meant to be a high-level overview, and then to show like a very simple example of how you might use this sort of data modeling in practice for analytics purposes. So before we go right into data modeling, I just want to talk a little bit about Superset first. So for those of you who might not be familiar with what Apache Superset is an open source BI platform that works with nearly any SQL-speaking data engine and offers a large variety of charts to create dashboards and visualize your data. And within Superset, there are typically two main workflows. The first being Explore, which provides you with a no-code chart builder. And Superset itself will generate the queries on behalf of the users via SQL Alchemy and query this data to the database that it's connected to. And it's typically going to be used by people who are just looking to gain insights from your data without having to be too technical. So you can think about like your data explorers, your less technical analysts, and your data consumers. The other is supported primarily through SQL Lab, which provides full SQL IDE. And Superset users create the queries, which remain untouched by Superset and is run directly against the target database. And this workflow will typically be used by your more technical data consumers, like your data engineers or data scientists, or even your more technical like analytics engineers, for example. So what is Preset? Of course, this is a Preset event. We're going to have to talk a little bit about it. So Preset Cloud is a multi-workspace cloud-hosted superset with all of the capabilities of Superset. We layer onto SOC 2 compliance. We have end-user documentation provided. We have different things like row-based access control and single sign-on, as well as a world-class support team and an embedded SDK. And keep your eyes on your email for some sort of an embedded event demo sometime in the future. And so what is Preset Managed Private Cloud? It's Preset's BI platform available for your AWS private cloud, handles all of your data security and compliance, frees you from that hassle. So with that out of the way, let's talk a little bit about what data modeling is. So for those of you who might not know, it might sound kind of self-explanatory, but I'm going to go into it anyway. So data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between data points and structures. The goal is to really illustrate the types of data used and stored within the system, the relationships among these data types, and the ways the data can be grouped and organized, as well as its formats and attributes. So data models are typically built around business needs, and we'll walk through a simple example here within the presentation itself, where the rules and requirements are defined upfront through feedback from business stakeholders, so they can be incorporated into the design of a new system or adapted into the iteration of an existing one. So your data models aren't just some static thing that never changes in the future. Of course, new data comes in, you're going to create new data models, you're going to augment specific data models, maybe get rid of other ones, but it's all part of this sort of data ecosystem. So data can also be modeled at various levels of abstraction, where the process begins, again, by collecting those business requirements from your stakeholders and end users, and the business rules are then translated into data structures to formulate a concrete database design. You can think of a data model like a roadmap or an architect's blueprint, some sort of formal diagram that facilitates a deeper understanding of what is being designed. And data modeling employs standardized schemas and formal techniques. Some of you may be familiar with UML, Unified Modeling Language. That's what you're probably going to notice here. And this provides a common, consistent, and predictable way of defining and managing data resources across an organization or even beyond. Ideally, data models are living documents that evolve along with changing business needs, and they play an important role in supporting business processes, planning IT architecture and strategy, And data models can be shared with your vendors, partners, and industry peers. And anyone who's ever, sort of had to go through the exercise of creating a new database, ingesting new large quantities of data, they know just how important this process can be to take seriously upfront, because the downstream costs of that can really exponentiate if you don't do this kind of thinking ahead of time properly. So now let's talk about the types of data models. So the first is what we call a conceptual data model. And these are also referred to as domain models. And what they do is they offer a big picture view of what the system will contain, how it will be organized, and which business rules are involved. We're using UML here, but typically conceptual models are created as part of the process of gathering initial requirements, and they don't have any specific notation. This was just UML for the sake of it, but it can be something as simple as just showing this like rough architecture, this layout, so you can get a sense of what does this data mean, what do we actually care about, and what are we modeling. So in our conceptual data model example here, we see we have like a time table, a product table, a store table that we're sort of joining together, and we will see what it means to make this less abstract to create our notion of a sales table for this business. The second one is a logical data model. So now it becomes less and less abstract as we move up in this data model, in the types of data models. They provide greater detail about the concepts and relationships in the domain under consideration. And one of several formal data modeling notation systems are now going to be followed. So this is when you would start putting in your UML, you would start labeling things as like your foreign key or your primary key. That's what PK/FK means here. And you're also going to indicate the data attributes, such as their data types and their corresponding lengths. So in this case, it's just identifying what your keys are and how you're sort of creating any sort of derived data model. And logical data models can be really useful in a procedural implementation environment, or for projects that are data oriented by nature, like data warehouse design or reporting system development. The third, then as we move down this sort of ladder, we get to our physical data models. Now, this is where we provide a schema for how the data will physically be stored within the database. So there, of course, these are going to be the least abstract of all of your data model types. They offer a finalized design that can be implemented as a relational database, and they include associative tables that illustrate the relationships among all of the different entities, as well as the primary keys, foreign keys that'll be used to maintain those relationships. Physical data models can include database management system-specific properties, including performance tuning. And we actually wrote a blog about this that you can go and find on the Preset blog site. I'll link to anything anyone wants to know a little bit more about, but where we talk about database optimization and what it means to really optimize these sorts of data types if you need it. So I realize I didn't walk through what this logical data model actually had, but essentially we're just describing what our dimensions are. So what is time exactly? It's a date. What is our product? It has a product ID. What is our store? It has a store ID. And how are we creating sales based off of that? We're using our product ID, a store ID, and the date that the product itself was sold. Once we get to our physical data model, we're actually defining what this data type is. What is the length of this data? Are we using varchars, integers, floats, dates, whatever it is? And then we're creating this, and we're also using formal notation now. So we're calling it what it is. It's a dimension table. And we will talk a little bit about what that means, but these are 3-dimension tables that we're creating a fact table off of, where we have a dimension time, a dimension product, a dimension store, and then a fact table sales, which is derived off of our 3 dimensions. So that's great, but why do we care about this, right? What exactly is the process and why do we gain any benefits from it? So let's talk a little bit more about the process first. So step 1 in any good data modeling practice is always going to be to identify the entities. The process begins with the identification of the things, events, concepts whatever it is that's represented in the data set that is to be modeled. Each entity should be cohesive and logically discrete from the others. So if you can't describe an entity, it's probably doesn't belong in your data model. You should be able to clearly and concisely create these sort of dimensions that we saw in the example. After that, what we're going to do is we're going to identify the key properties of each entity. So each entity can be differentiated from all the others because it must have one or more unique properties called attributes. So for instance, an entity called customer might possess attributes like first name, last name, telephone number, while an entity called address might include street name, a number, a city, a state, country, and a zip code. And you can use one or more of these attributes to create a primary key, but you need at least one that uniquely identifies the row of that entity. After that, what we're going to do is we're going to identify the relationships among the entities. So the earliest draft of a data model will specify really only the nature of the relationships each entity has with the others. In the example that I just mentioned with the customer and the address, each customer lives at an address. So if that model were expanded to include an entity called orders, for example, each order would be shipped and billed to the same address as well. These relationships would be documented via UML, which is Unified Modeling Language. And I won't touch too much on that, but that's really what all of these different symbols are. You're free to go look that up. I'm happy to provide resources or answer any questions about that later as well. After we have identified all of these relationships, what we need to do is we need to map the attributes to entities completely. This will actually ensure that the model reflects how the business will use the data. This is when also several formal data modeling patterns are going to be put into practice. The example that we're going to show is going to be a dimensional data model example, but something like, so object-oriented developers, for example, will apply like analysis patterns or design patterns, while stakeholders from other business domains may turn to simpler ones. So depending on what your background is, the way you model the data, whether it be hierarchical, using dimensions and facts, using a star schema, it's really how you internalize and create this like notion of your entities. For any of our developers out there, you can think of it as like OOP, but for your database. After we've done this attribute mapping, what we're going to do is assign keys as needed and decide on a degree of normalization that balances the need to reduce redundancy with performance requirements. So what does that mean? Normalization is a technique for organizing data models and the databases they represent, in which identifiers called keys are assigned to groups of data to represent relationships between them without repeating the data. So this is, I'm going to point out in the example why this might not always be the case when we talk about some of the other different types of data models, not the types of data models we talked about there, but the types of data modeling. That's the better term for it. And so, for instance, if customers are each assigned a key, we can use that key to link them to both their address and their order history without having to repeat the information in the table of customer names. This is where you're reducing your redundancy. Normalizations tends to reduce the amount of storage space a database will require, but it can cost much more to query when you're looking for certain things, which would be an argument for why you might not want to always normalize to this extent. But either way, once you've agreed, decided on some sort of degree of normalization, the last thing you need to do is finalize and validate this data model. Data modeling is an iterative process. It should be repeated and refined as business needs change. If you're selling new products, your stores have some new wing added to them, you need to track sales there. Your data models are going to change, which is why it's important to create these robust entities right off the bat and allow yourself the room to go back and modify this, make sure there's a solid understanding there so things don't break down the line. The more, hindsight is 20/20, but if you can think of this ahead of time and you can plan for these sorts of things, good data modeling will take you very far in any sort of your data needs. And so that was the process. So what are some of the benefits to this? We just reduce errors in software and database development. You're creating good data sets. You have proper data set checks put in place. You don't have to worry too much about what's going on there. You can rely on the correctness of the data. We're also increasing consistency in documentation and system design across the enterprise. I'm not sure how many of you, my background is in data engineering, for example, and often my internal stakeholders were analytics engineers. Now, this is just like a story that I can relate this to, where we would have multiple groups of analytics engineers focused on different aspects of the business. When we didn't have this sort of proper data model, this proper documentation available, there were often questions about what exactly is this data set? They were literally repeating each other's work without knowing that they were using the same data sets, writing essentially super long SQL queries to recreate data sets that existed simply because the data models or the documentation weren't there. That time can be better spent on, whatever it is analytics engineers do. So it's like you keep track of these things ahead of time. You spend the time in the beginning to save yourself much more time in the long run. Proper data modeling will also improve application and database performance. Like I mentioned, we wrote a blog post about database performance. You can go find it on the blog site. I'll link to it after as well. But the thing about normalizing, reducing the redundancy, reducing your storage space, of course, when you do that, you're trading for query performance. So you can also increase the amount that you're storing, which we call denormalization, and create redundant data sets, which improve your query performance. And I think most people tend towards query performance being the more optimal thing, the thing that they want to optimize for, because storage has become cheaper. That's just sort of how it is. So typically highly denormalized tables that you create dimension tables off of is your best bet. And it also really supports the philosophy that we have here at Preset and Superset, where we really try to hammer home the point of using a data set centric approach to querying and dashboarding, because it just makes everything much easier. When you have a clearly defined data set that has like a proper dimension to it that you can attribute to another table, you understand what it means, it's much easier to use, it's smaller. And when you query it, you're not querying you're not querying like a million row table, you're querying a subset of a dimension that exists in there, and you get some performance that way. So after that, it also eases data mapping throughout an organization. No one needs to go back and forth asking about, oh, what does this mean? What is that? They clearly have these relationships available to them. It makes it easier for them to understand what it is they're going in and trying to find something in. Improves the communications between developer and business intelligence teams. If you've been a developer, you know just how weird it is sometimes, like, oh, the business side of things. I have no idea what they want. You put out something that turns out didn't meet their requirements because they never even told you what the requirements were in the first place. I'm biasing this from the developer side of things, but things like that happen. If you are forced, if the developers and the end users are forced to like actually communicate and put together this sort of model in the beginning, that sort of gap gets narrower. It's always going to exist, let's be honest, but you can do some work to try to reduce the effects of that. And then finally, it's just to ease and speed. It's just to ease and speed the process of the database design at the conceptual, logical, and physical levels. It's just being told, okay, I want all of our sales data available isn't super helpful. Being told, okay, we have these 3 things that we track and we want to create sales based off of what the product is, what was when it was sold, and from what store it was sold. Much simpler. You have a better picture in your head of how this is going to be created. So now what I want to share, I'm going to talk. So I mentioned that there are different types of data modeling processes, and I'm going to just briefly touch on 3 of them. So the first is what we call ER data models. These are entity relationship data models, and they use formal diagrams to represent the relationships between entities and databases. That's sort of what we just saw in this presentation. There are also object-oriented data models where the objects involved are essentially abstractions of real-world entities. You can think of the exact same concept of like object-oriented programming applied to your data, if you're familiar with it. But object-oriented databases can incorporate tables, but can also support much more complex data relationships. And this approach is typically used in things like multimedia or hypertext databases, as well as other use cases. But that's where it really shines, where your data isn't super structured, where you have like an email. How do you parse an email? How do you structure an email? You just call it an email, and you work from there. What I'm going to show an example of is a dimensional data model, which is typically what I've seen in my data engineering career as being the go-to for most things, where this was something that was developed by Ralph Kimball. I think he wrote like the book on data modeling that everyone has probably heard of at some point. And they were designed to optimize data retrieval speeds for analytics purposes. That's what the purpose of most of these data systems are. So while relational and ER models emphasize efficient storage, dimensional models actually increase your redundancy in order to make it easier to locate information for reporting and retrieval. This modeling is typically used across like OLAP systems, but the reason is we want to query this large pool of data. It makes sense to create this sort of redundancy as different dimensions, so it's easier to see. Oh, the name of the book, I think it's literally called Dimensional Modeling by Ralph Kimball. I'll send a link to it after. I just saw it in the chat. Kimball's Data Warehouse Toolkit is another one. But yeah, so the example that I actually wanted to share is I'll show the dashboard first, because I think that's always probably the most interesting thing, not the data sets. 1 sec. So what we have here is, for anyone not familiar with what a city bike is, popular bike sharing system in New York. I'm sure these bike systems exist everywhere else. I'm just very familiar with city bikes, big fan of them. And what we did here was we essentially created a sort of summary table. So a little bit about the data first. So the city bike data actually comes in as a highly denormalized snapshot. And this is why I kept alluding to this dimensional data modeling, because you're going to see exactly what kind of redundancy exists in a second. It comes in as a massive snapshot where, you know what, I can actually probably show you the schema here as city bike trips with all of these different columns. Let me just make that bigger for everyone to see, where essentially the way this system works is you grab a bike out of a dock, you take a ride on that bike, and you park it somewhere else. So you have a ride ID, you have the type of the bike you're using, when that ride started, when that ride ended, what station you started at, what station you ended at. You have your latitude, longitude for other purposes. It doesn't matter if I don't know if that's interesting to anybody, but for geospatial purposes, it's really cool. And then you also have like a member status. So these bikes are typically available to anyone. If you have a working credit card, you can go and check a bike out, or you can pay for a subscription where you're just billed one flat fee. Sorry, I just lost my train of thought because I just saw the question. Yeah, you pay a yearly subscription, you just grab a bike, you go, you get 45-minute rides. So your subscription status is also something that's available. Now, this is what the snapshot data contains. So someone said, is there a GUI tool suggestion to define, enter, visualize those models that can be used? Yes, I was just getting to that, which is why I was like, how'd you know what I was about to go to? DBT. DBT is the one we recommend most, and this is known as data build tool. And what you can actually see in my databases is I have this. So Snowflake, you can think of as a data warehouse with multiple databases. My city bike trip data, think of it as like a staging database where I'm getting my raw data, and this isn't a live system. This is a snapshot and stuff, but for the purposes, you can imagine this is where you would be ingesting every day's ride history and all of that. And what DBT actually does is it creates a new database for you called analytics. Now, this is sort of what the IDE looks like, but I'm going to just go directly to my GitHub, and I'm happy to share this with anyone if they're interested in seeing it. how to set up maybe a DBT project to begin with. They all followed this pretty standard file structure. And going back to my tables, we can see I have this like member trips, non-member trips, ride history, total rides by status, city bike trips, and station status. What is all of that from this one? City bike trips is actually just a duplicate of the other table, just for my purposes. You don't typically need to do that. So if I go back to my models, this is how a DBT project is typically organized. And we've done an event on DBT where I actually went super in depth. We only have like 15 more minutes, so I won't go too much into the DBT tooling itself. But if you have any questions at all, feel free to reach out to me after this. I'm happy to talk about this anytime you want. There was someone we're working as a partner with. We have a native integration and everything. So the way DBT works is we don't need to talk too much about like the assets, macros, or anything. There's a big models directory. Within your models directory, you can of course create subdirectories. And what I have here is GBFS is actually the I can't remember the name, but it's like the general bike feed share. And typically any one of these bike sharing systems all go to like GBFS. I wrote an article about this, like a post about this too. It explains the data set more clearly, what all of this stuff means. Feel free to check that out if you're curious about it. But this was the live feed. So as bikes are being checked in and out, there is a live data stream that you can ingest. And this was what that model was for. Historical is what I actually used to create my city bike trips table. And all I did was I recreated it from the source, which was my city bike trip. So you can see it says city bike trip data.public city bike trips. That's my city bike database itself. So DBT is a really cool tool because what it can also do is it can connect to Snowflake. So I'm using Snowflake here. Oh, it's all on the preset blog site. I'll share everything at the end of this demo. But so what it does is it also hooks up here, and it knows it can access these directories here. So I can call it to literally just do a simple select star on that. And this is how I created my first city bike trips table, which was exactly the same as the staging table that I mentioned. Now, we talked about dimensional models being sort of derived. And I was just talking about like how a data set centric approach really optimizes your query performance and your just in general, your querying experience, because that's where we're going. We're going towards fast analytics. We don't have a data wait for a reporting page. We want to be able to query, just figure out what's going on and move on. So that's sort of the purpose of this. If we go to the models and we look at what the derived are, here is where you'll see all of these other tables. I can't pull that out because I'm sharing the window, but here's where you'll see all of these other tables. And essentially what DBT does is it allows you to write modular SQL. So the configuration, you don't really have to worry about, but this actually just says materialize it as a table. All I'm doing now is I'm selecting everything from my new not staged city bike trips where someone is a member. So I'm essentially performing a filtering on it, but I'm making this available to myself as a new data set. Because if I want to query my giant city bike table, and I only care about like marketing to my members, for example, what's the point of that? Why not just have a members only, because you're trying to give away coupon codes, make sure that people are, renewing their subscription. It's a separate marketing campaign than you would to non-subscribers. They need a different approach. So you have this sort of dimension of members only coming out of the larger table. And you can also see that right here, where if I just go and look at the members trip table, it's literally the exact same schema. It's just a much smaller table. And I believe you should be able to see the size of those. You can see the row count, actually. There we go. So like 24.4 million rows versus 33. So you can see the majority of people are actually City Bike members. Most people don't just go and grab a City Bike and go. But you can also see here our non-members, we have about 8.5 million of them. And what else was interesting in there? So we also have total rides by status, which we use for a visualization. Yes, it would be a dimension, but it like that's where the line sort of starts to blur, but it does include facts such as ride time. The reason I wasn't calling it a fact table though is because things like ride time already came from the original snapshot that we created this dimension off of. But so I also created this sort of ride history where all I did was take the ride ID and I broke it out. So I'm not interested in whether a member or a non-member did this ride. I'm interested in literally seeing what the path of the ride was. Who took bike from where and where did they end up leaving this bike? And this is something that's probably really important to optimizing. Like, where do we create a new station? Where are we seeing, overloaded docks or super empty docks during rush hour when it doesn't make any sense? Oh, we probably need more bikes, more stations around this area. It really just helps you put together a more cohesive or like robust story around this analysis. So now that I've sort of explained all of those tables, we can see what the impact of that was. So here within Superset, we can actually see what the query is that creates this. And all I'm doing is I'm simply counting out my distinct ride IDs, grouping it by member and casual. In this case, and I'm just trying to see where the data set is. Right, I can just show the data sets first and how they're loaded. So the thing that I mentioned where DBT creates its own database, that's why if you notice in the drop down, there was Snowflake. What I'm actually connecting to is my bike DBT demo, and that's where all of these physical data sets exist. So any of those visualizations you just saw, the query they run is against that data set in my Snowflake warehouse. No, it does not. That's to Ahmed. The IDE doesn't have a visualization tool itself. No, it does have a table. So if you were to just run a query through SQL Lab, for example, you'll probably see some of my weird queries or whatever pop up, but those would you would be able to see the results. You can still run simple queries and just sort of get a general sense of what's going on. I'll wait for that to load. Oh, that's the whole point of a Superset. It already comes with all of the dashboarding for you. So I can literally go here. Let's find this real quick. Like if I click right into charts, for example, you can get started by creating a chart here. Internet connection's a bit slow, but you grab your data set and yeah, that's exactly sort of what the process is. You can click into the data set itself. So like I can show one of the simple ones. So like here we can see what the query itself. So I never wrote this query. That is the one thing I wanted to point out. Seems like a very slow day. Yeah, so I never wrote this query. All I did was I went and configured what we call a big number. What is a big number? I literally pick my chart source, which is what the data set itself is. And here it's the member trips. I grab the column itself, and what the metric was a distinct ride ID. So that wouldn't be there originally. I just dragged it in. You create that, you save it. Like I can update this chart. Not a big deal. But essentially, you can create any sort of these visualizations depending on what your data set is. You should probably pick appropriate visualizations. Some won't make sense for what the data is or what you're trying to see. But if I just wanted to go up to this plus button and create a new chart, this is where you would see everything we have. So popular, with the trend line and all of that. And here's like an example of that where, again, never touched any of it, but if you look, the query that's generated is actually pretty complex, where we have a big number with a trend line to sort of show, and there is a time filter here. So over 1 month, how many rides are we getting? This is a Joseph. We do have documentation about all of this available. So I guess we probably got a good sense of what's going on. The real purpose of that dashboard was to kind of show the data sets and everything. I could actually just move right over to questions. I'll just show the second part, the station statistics. This is always my favorite because I feel like it looks the coolest, but let's see if this loads. So we actually can create this arc the sort of arc diagram of all of the bikes. So you can see each station and where the bike came out of and where the bike ended. Thank you, appreciate it. And that's what the use of like that ride history table was. So what I did was I essentially grouped everything by their start station, end station, and counted the total number of rides that were there. And you can see like people really like starting at this specific address, must be a popular commuter line. Okay, but with that, you know what? I can wrap it up because we only do have 5 minutes. So I'll take some more of the questions. I can stop sharing this. And yeah, it's because I did see a lot of good ones here. So thanks. SAD SDA sent some of the docs to Superset. We also have the docs available at Preset. But if you want to learn about specifically your data connection, I'll jump to the Q&A in a second, but let me see. Do you usually join your mention tables? If you guys have questions, would you mind using the Q&A, please? And the data is open. It's available to everyone. City Bike makes it available on an S3 bucket. You can go and just import the snapshots themselves. I'm just going to take a few of the questions I see in here before I hop to Q&A. By visualization, someone asked about configuring the data sources. So one second. That's all going to be at our doc site. Preset.io, which is right here. And it's actually one of the most popular topics. So you should see a big box that says that. So I'm going to just hop into Q&A where people have asked the other questions. So we are on mute. Yeah, you have to type. So I'm just going to answer live there. Thank you. So any GUI tool suggestion to define, enter, visualize those models? Yes, like we mentioned DBT. So DBT also has a fully functioning like lineage option that you can actually see. And here, I will actually send a link to the original blog post I wrote that really shows all of this. And it includes the same data as well. Just trying to find it. There it is. Using dataset-centric model, visualization in DBT. I will type the answer here. And I'll also put it right there. So this might give you a better picture if you're interested in the whole DBT. How did I create these things within DBT, download this data? This should hopefully answer all of your questions. Is there any mechanism to sync models defined in preset and external modeling tools? It would depend on what the modeling tool is. Oh, physical models defined in preset. Yes, all the physical models are straight up SQL. So physical models, let's separate this for a second. What we call a physical data set is actually coming from your database. Superset does have a thin semantic layer that you can use to create what we call virtual data sets. You would do this via the SQL lab. And essentially, in that example, you saw that I had SQL queries within DBT itself that were being run against my database and creating these new tables. You can use this as a functionality, but it's not like the most scalable solution to it. But it does answer the question where, yes, you can create these virtual data sets. It won't materialize as a view or anything. It'll be something that constantly requeries and hits your database, refreshes, but you can take all of that and import it back out. That was Umit's question. And then this is unrelated, but curious to know, in a preset dashboard, how do you place multiple tiles within a single column, whereas only a single tile in other columns in the same row? I have never been a front-end engineer. I agree with you. It's a little difficult, but it's not too bad. You have to play around with it a bit. That's not really if you go to, I guess, let me share my screen one more time then. Share that window. This is for the anonymous question that I see. You actually, if you go to edit dashboard, you have to kind of play around with the column sizes. So you can create one column and then put a bunch of element boxes into it and then size each chart there. That's how you can actually see the rough outline of how this was created that way, where I played around with this a lot. This is one of the first things I created for Hackathon here, so I had the time. I agree though, it's like if you know CSS, HTML kind of stuff, this should be a breeze, but it takes a little bit of practice and playing around with. But layout elements and all of this stuff is here. If you do have any questions about it later, I'm happy to take it offline and answer it for you. All right, now I'm going to go back to the chat and see what questions we have in here. ER diagrams generated. Yes, within the lineage documentation, which I don't have available to me, sadly, because this isn't running, but there's usually, there's a simple command and it'll show you, it won't show the fields, but it will show the relationship of how each model connects to its downstream sources. So okay, now I'm going to go to the questions that I see in the chat. Can we power, oh, let me scroll up. There seems to be a bit. I've always had plans to use preset. Okay, so hopefully that question was answered. Do you usually join your dimension tables to a fact table in another DBT model, which then acts as a physical table, or do you do the joins in a virtual data set within Superset? For best practice, I would say when you're performing these types of joins, this is Mark's question. Perform all the joining, everything within your database layer itself. The more concrete or the more like well-defined data sets you can create, the better your experience will be with Superset and Preset. If you have these like simple sort of data sets already ready to go, it's much easier to go in and hop in and visualize it. So create the joins, do all the relationships ahead of time. You'll get a much better experience out of everything. Kelly, I believe I did answer your question. It's available to everybody in an S3 bucket. Question on the map chart. Can we power Google Maps to the chart? I believe this is actually a Python. This is a different library. I don't know enough about that, so I don't think it's a visual. It's an open source Python visualization tool, like Mapbox. That's what it's called, right? So I don't think you can power it with Google Maps. Mapbox will just work the way Mapbox does. That was Suman's questions. I think preset. Oh, and Naveen answered the question. Thank you. I didn't see your answer. As Superset is open source, can we change the integration of the map? What exactly do you mean by the integration of the map? I'll come back to that. Liaison's questions. How to determine the level of denormalization? Maybe you can. So denormalization is actually like blowing your table up into, like, think of it this way, where the more you denormalize a table, the more columns you actually have. So you're just basically so if you think about a customer address, all of that, imagine if you had a customer along with their address table. That's what we would call highly denormalized. Typically, if you are going with best database design practices, you should have this historical data, the snapshot. In the case of disaster relief, like disaster recovery, you need to go back and get your data. They should already exist. And again, you have to remember the storage on this is massive. So using like, I don't know, something like Glacier, any sort of like frozen storage would be your best bet, but just keeping it there. If you mean normalization, again, that's going to be more towards what your business needs are. Is storage a constraint for you, or do you know, for example, that this isn't a data set that, many people are going to be querying very often, so it doesn't really matter, you don't need to denormalize it? That's really going to depend. If you reach out to me, let me just type my email here. I'm happy to go and find some resources for you, and I can send them your way after. So does Superset have a yes? So like I mentioned, Superset does have a transformation tool. It's our virtual data sets. I would always recommend doing your transformations as prior to the visualization layer as possible for your best experience with Superset and Preset. Can we join to? Yes, you can do that. The performance. So you would just essentially create a chart based off of the virtual data set, The performance of that chart, though, if this becomes like a mission critical thing, you have to remember you're going to be running this like joining query against your database every time you refresh this chart, every time you're trying to update the data. From Mapbox to Google Maps, I can find out about the Google Maps stuff for you. But it looks like, oh, okay, some more. Is it possible to integrate preset to Django? Oh, that would have been a great question for Evan. Mehdi, if you don't mind, you can also find me on the Superset Slack. If you ask me that there, I promise I can find you a good answer for that. I'm not aware of that. This one's for Mizba. Is there any limitation set on number of users who can be? So we have a forever free tier. You can have up to 5. After that, it is on a per user basis. And again, I'm not the most familiar with their billing, but up to 5 for free forever. That I'm aware of. Once your team grows, I'm happy to put you in contact with any of our salespeople and they can talk to you about it. Cool. So it looks like I've gotten through everything. So just one more time, feel free to reach out to me on, does preset customize the charts based on end users' requirements? Do you mean, does like a support team at preset help you customize the charts, or can you customize your chart? Oh, so yes, we do, like within preset, we support things like row-based access control, single sign-on. You can set data access policies, everything. So if you know, for example, like you have sensitive data, all of that is possible within preset. You can set up these access control policies and sort of, whoever the master of that domain is, they would take control of that process. But it makes it, you can obfuscate data from whoever it needs to be obfuscated from. You can show the data to whoever needs to see it as well. We're only 5 minutes over. I can give it another 2 or 3 if anyone has questions. Otherwise, I'll talk really slowly. It was great presenting. I hope you guys got something out of it. Again, feel free to reach out to me on everything. This is what you'll find me under in the Superset Slack. And this is my email one more time. Thanks for your time. I hope you enjoyed it. Yes, I will be uploading this to YouTube soon, and anyone who signed up will receive an email for it. Yeah, you can add me on LinkedIn. Oh, the book. Let me just Google it real quick for you before I go. I don't want to leave you hanging on that. Kimball Dimensional Modeling. There's a PDF actually available for it too. Dimensional Data Modeling. This was the one I was talking about, and someone put in this data warehousing one, which seems interesting to me because I think I heard about it, but I never actually ended up reading it. But highly recommend dimensional data modeling, especially if you're like interested in being a data engineer for any reason. Awesome. I'll call it there then. It was great. I appreciate all the questions too. Feel free to reach out anytime. Oh.